So welcome back, learners. Now jumping to our second concept, whereby we're going to be looking at a circuit diagram. We need to remember that in a series circuit, there's only one pathway for the electrons to follow. So electrons are following just one pathway, but then that's only if the circuit is connected in series. So the current flows at the same strength everywhere in a series circuit. So that means now, at whichever point we choose to measure our current strength, it is going to be the same because it flows at the same strength everywhere in a series circuit. Why does that happen? Because there is only one pathway for those electrons to follow. So at whichever point that we try to measure this current strength, it is going to be the same because of this reason. So because of that, we're saying that the current is the same at all points in the circuit because the circuit is connected in series. However, if you add more resistors in series, the whole current, the current in the whole circuit is going to decrease. So if we add more resistors in series, in this case, on this particular diagram that we have two resistors. Remember that our light bulbs are examples of resistors. So that means if I add another light bulb in this series circuit, the resistance of this entire circuit is going to increase. And by increasing the resistance of the circuit, I'm actually decreasing the current. So that means the current and the resistance, they have a certain relationship that when one increases, the other one needs to decrease. So why does then the current stay the same at all points? The electrons in a conductor normally drift in various directions within a metal, as shown in this particular diagram that we have. So all these electrons that we are finding in a conductor, they are just drifting in various directions. There is no specific direction in which these electrons are drifting towards. However, if now you start to build a circuit, so when you build a closed circuit with a cell as an energy source, so that means if we are adding a cell as an energy source in that particular conductor that had the electrons that were drifting in various directions. So when we connect an energy source, being the battery or a cell, the electrons will begin to move towards the positive side. So now that means the electrons will start now going to a certain specific direction, moving from the negative terminal to the positive terminal. And now, the rate at which these electrons move is going to be determined by the resistance of the conductor. So remember, if the conductor has a high resistance, that means the rate at which these electrons are going to be moving will be very low, because we're saying that when the resistance increases, the current is going to be decreasing. So if this conductor has a higher resistance, that means the current strength that is flowing in this particular conductor, it is going to be low. However, if now the conductor has a low resistance, that means the current strength flowing in this conductor is going to increase, it is going to be high, because of the relationship that these two variables have. When the current increases, resistance must decrease. But if the current is decreasing, then that means the resistance of that circuit was increased. Now, the current also, why does it stay the same? There are electrons everywhere in the conducting wires and electrical components. So all the wires that we are seeing, remember that all matter everything that we're seeing around us is made up of matter, and all matter is made up of atoms, and your atoms are made up of protons, electrons, and neutrons. And these two, the protons and neutrons, are found in the nucleus of an atom, and the electrons, they form an electron cloud around. So those are the ones that you're actually seeing in the picture that I have here. So those now are found in this conductor, and they are moving in various directions. So because it's a conductor, it's just matter, it has electrons, it also has protons and neutrons. So when the circuit is closed, all the electrons will start moving in the same general direction at the same time. So initially, when the circuit was opened, or rather when there was no battery or energy source connected, the electrons were just moving in various directions. The moment you start connecting the battery or connecting the energy source in this case, the electrons will then start to move in a certain general direction. And they are moving at the same rate in the same conductor. So this is why a light bulb turns on immediately when you switch on the light. So when you close the switch or when you switch on the light bulb turns on immediately because there are electrons in the wire. So it doesn't mean that if this is your house and this is your plug there and your light bulb is there, it doesn't mean that immediately when you start pressing on the socket there, the electrons will start now to move from the socket, run all the way to the light bulb. Already on these wires that are connecting the socket to the light bulb, there are electrons. So once you switch on the light, the electrons, they start to move in the same direction, so that the electron that was at the end of that wire will start moving towards the resistor and therefore produce the light. It doesn't mean that the electrons will start moving from the socket, run all the way to the light bulb to produce the light. They are already there because, as we are saying, the electrons are everywhere in the conducting wires and the electrical components. So in a series circuit, all the electrons travel through every component and wire as they travel through the circuit. So we are saying that as our electrons are moving from the negative to the positive terminal, they are going to travel throughout the entire circuit. So they are going to be traveling through every component, through the ammeter, through the resistor, through the ammeter again, and through the other resistor, and then again through the other ammeter. And also remember, they are going to be transported or basically traveling through the wires that are going to be enabling them to move from one component to the other component. So basically what you're saying that all the electrons, they are going to travel through every component. They're going to travel through every component and every wire that we have in this particular instance. So all the electrons, they are going to experience the same resistance. So in series, all the electrons are going to experience the same resistance because there's only one pathway for them to follow. So if that path has a certain resistance, that means all the electrons following through on that path will experience that resistance, which is why we're saying that they are going to experience the same resistance. Therefore, they are all going to move at the same rate. This means that in this diagram that we have here, the readings on A1, which is the ammeter 1, ammeter 2, and ammeter 3 is going to be the same. So in summary, what we're saying is A1 is going to be equals to A2, and that's also going to be equals to A3. Remember that A, that's now a symbol used for ammeter or for amperes. So we know that our current is measured in amperes with the symbol A. So basically, also A denotes that there is an ammeter that is being connected in this circuit. So as our electrons are moving from the negative terminal to the positive terminal through the wire, passing through the first ammeter. So this ammeter is going to register a certain amount of current. Now that current will be the same as the current which will be registered by ammeter number 2, and that ammeter number 2 will register the same current that was registered by number 1, and also that will be registered by ammeter number 3 as your electrons are moving through the wire and also through the resistor through to the ammeter number 3. So we are saying that at every point the current is also going to be the same. However, we are saying that as we add more resistors in series, the resistance of the entire circuit is going to increase. So if I were to add another resistor here, to now have a total of 1, 2, 3 resistors in this particular circuit. If I add another resistor in this circuit, the total resistance of the circuit is going to increase, and therefore the current strength is going to decrease. So remember, we are saying that the voltmeter is going to measure the voltage, which is measured in volts with the symbol V. The ammeter is going to measure current, which is measured in amperes with the symbol capital letter A. And then the last one, being our resistors, are going to measure the resistance, which is measured in ohms, and the symbol for that is the sign for omega. So all of these are variables. They have a certain relationship. We have identified that when the resistance is increasing, the current is going to be decreasing, assuming that the voltage, it is remaining the same. So in whatever that you are trying to do here, something must be kept the same, and then we can discuss change one and then measure the other one. In this case, Voltage is going to be kept the same, and we're going to be discussing the two as what happens when each of them are connected, and also what happens to the strength, and what also happens to the strength and the resistance of the entire circuit. So with all of that said, I hope you had as much fun as I did learning about the series circuit, and until I see you next time, goodbye.